This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient code by using Java persistence annotation. If you've always wondered how should we actually map these two entities together, these two Java classes, these two tables, then this video is something for you. Complementary to this video, we have related articles and links in the description below. Please take the time to like, subscribe, and hit that notification bell so you know when we have the next video coming up. Without any further ado, let's get started. So the problem that we want to solve with JPA, Java Persistence Annotation, is that we have an application that needs to extract or communicate with the database and thereby extract data and also execute operations like create, read, update, and also delete data from the database. And in the old days, then the developers would actually write the SQL manually inside the application, and then it would be SQL that would be fired directly against the database, and then the result was then retrieved to the application. But there was multiple problems with this. One problem, of course, is if you want to change the database to another database system, then you had to change all of your SQLs, your SQLs, because all of your SQLs, those are specific to a database type, and they might not work to another database type. That is one problem. It was not the main reason, but there was one problem that we wanted to solve with JPA. The other problem is that that is also security. It is much more secure if you do not have to. If you don't have to think about SQL injection in all of your SQLs, so whenever you have a string with SQLs, then if you were quite smart, then you could actually inject SQLs into your database, and then you could actually get that result in your onto your website or onto your application, and you could actually also execute commands if you are not careful with SQL injections. So security was also a big part of it, and the third part was also that Java developers are very good with Java. Why do they also have to understand SQL in a deep way? And that was also what JPA could actually solve, because then we could just annotate the classes, the entities, the data entities. We could just annotate those with whatever we want to annotate with, and we could create our relations between our entities with JPA. And then we have something called Hibernate that then could take that JPA, the annotations, and then they could actually be converted into SQL. And then the SQL would be fired against the database, and we would get a result back, or we would execute a command like delete a row, or update a row, or insert a row. So that is the story behind JPA. This video will focus on the relations between the entities. How will we create and set up the relations? It is always it's a little bit scary to begin with, but when you have made the first relations, the first couple of relations, then it is actually quite simple. And if you know the structure and the ideas behind the relations, then it's much easier. And there's actually not that many types of relations. We have a one-to-one mapping. That is if one entity always equal to 0 or none other entity, and there's a one-to-many mapping, and there's a many-to-many mapping. So there's actually only 3 types of mappings, but there are different ways of actually executing these mappings with. So that is a focus of this video right here. Let us go to some hands-on already. That is the best way to learn. And I'm using IntelliJ, and the best way to get a project right there, where you can use JPA and where you can use where you can insert stuff into a database, that is by pressing File, New Project, and then choose Spring Initializer, and then you will give it a good name. And then you can choose Maven or Gradle. That's up to you, whatever you prefer. Then I'm using Java 19 right now, JDK 19, and also compatibility with 19. And then you can press Next right here. The way that I created my project right here was that I ticked off Lombok, because I don't want to. We get a lot of boilerplate code for free with Lombok. And then I added Spring Web, so I could create some REST endpoints if I wanted to use those. And then I added data. Then we have to add data, Spring Data, Spring Data. Let us just JPA. Spring Data JPA is right there. You can also need to take that one off. And then if you want a memory database that starts up every time your application starts up, then choose H2 database, because then you don't have to think about starting up a Docker container with, for instance, Postgres or MySQL to have a local database that you need to that you can play with. Just use H2 database to develop against. It is also recommended that when you want to create an application that when you develop locally, just use H2. It's much easier. It's in memory, and then when you go to when you want to deploy to a development to a test environment or integration environment, then you just use your real database there. For instance, Postgres is a good example. And of course, we're talking about relational database databases right here. We're not talking about the NoSQL databases at all. That is not a part of this video right here. Then you press create, and you will end up with a project like this. I've already created some examples with a lot of joins, but we will actually start all over with a new join, and I'll show you how it is actually done. Step by step. So first of all, let us say that we have some fruit that we need to we have some fruit that we need to transfer. We need to transport some food or deliver some food somewhere to somewhere. Then we would actually have a delivery bike that can actually transport exactly one basket of fruit. So that is a one-to-one relation, and that is the one we will start with. And then after that, then we will actually have maybe multiple pieces of fruit that can go into the basket. That will be a many-to-one, because we have many pieces of fruit that can go into the basket. Let us start with the delivery bike to the fruit basket relation. So the first thing you always want to do is you want to create your entities. You have an entity that's just a representation that is usually it is equal to one table in the database, but you actually don't have it doesn't have to be exactly one table. But that is a bit more advanced topic. In this video right here, one entity will always be equal to one table into the database. So we will just create a new Java class right here, and that could be fruit basket like this. And then the first thing you want to do is you want to annotate it with entity like this, and you can see that comes from the package JavaX Persistence. So you want to annotate it with the add entity. If you want to decide the table name itself, then you also annotate with table. And here you can then give it a good name, like name fruits _ basket. And here, of course, you can write whatever you want to write. Per default, the camel case will actually be converted into snake case, which is where you have an underscore in between fruit and basket, by default. So then we already got an error because this is IntelliJ, and you can see that we actually we have an entity right here. And the first error is that we need an ID. So you always need an ID. That needs to be something that can actually identify each row, each object, if you will. And that is, the short thing is here is just to write, just to create an integer and then have an ID with the property name ID right here. And now the error actually disappears. And actually, this is actually enough. So now we actually have an entity. We could actually create some fruit baskets now, but you would only have one column, and that would be the ID. And so that is not that interesting. So we need to give it some fields. We need to give it some properties. This fruit basket right here. So we will give it a private. It could have a color, maybe. It could have a color, and it could also have a. It could be a max weight or something like that. So maximum weight, but how many or maximum weight. How much food can actually carry before it breaks. So that is our fruit basket right here. There's a color and a max weight right here. And that's actually it. So, and since we have only used primitives or wrappers of primitives, and integer with capital I right here, that is a wrapper of the int, and double, of course, is a wrapper of the double. So as long as you use primitives or wrappers of primitives, then JPA just says, okay, that's fine. Then these are actually columns that you want to create in the table, and there's no problem with that. That's quite easy to understand. So it is only when you start mentioning objects We will not do that now, because we will need to create the delivery bike first, and then we will actually join these two together. So I'll create a new class right here, and I will say this should be the delivery bike. Again, we need to say that this is an entity. This time I will skip the add table because I just wanted to have the default name. But I want to give it an ID right here. And this is again private integer. And then we give it again, just say that this should be named ID. It is good practice just to name it each column, each ID column, ID on each table, and then if you have a reference to another table, then you prefix the ID with the name of the other table. But we will come to that actually. So here we have the ID again, and then this bike. What should this bike? This can have a the bike. It can have a it could have a description. It could also have an owner, so like a person that actually owns this bike. So, and it could also have maybe a number of wheels. So, in wheels. Again, I will actually write wheels like this. So this is number of wheels on the bike. It could be, one of those tandem bikes where you actually have 3 wheels on there. Usually there's only 2 wheels on that also. So maybe number of wheels is not that good. It can actually have 3 wheels if you have the if you have the special bikes that can take a bit more weight. I'll skip the wheels. So we have the description and we have the owner right there. So that's quite good. So now we actually have our 2 entities. If I wanted the column names to be something else than description, for instance, then I can write column like this, and then I can actually give a new name, like instead of description, then this could be bike description, So now the name of the column for this field right here would actually be bike description instead of just description. So now we have 2 entities, and we would actually like to join these 2. We would like to create a relation between these 2 right here, the delivery bike and the fruit basket. And we know it's one-to-one relation. The delivery bike can always only have one fruit basket attached to it. So it is a one-to-one, but of course sometimes there will be no fruit basket. That's also okay. So it will be a one-to-one or 1-to-0. But that is actually the same when you say one-to-one. Then it could actually also be 1-to-0. Then you have to decide on which side where you want to create the join. It matters a bit when you want to save and when you want to handle your entities. Then it's good to actually have a kind of a master where you actually put the objects on and create the relation, and then you have like the child, which is not where the relation just happens on. And in this situation right here, we want to mention the relation on the delivery bike. So this means that right on the delivery bike right here, I would actually have a private fruit basket like this. And then we have this basket right here. And now we get an error because we have to tell JPA how should these 2 classes actually relate? How does these objects relate? How does the tables relate? And that is there are multiple ways of doing this. The easiest way and the most used way is actually that each of the fruit baskets would actually have an ID that points to the delivery bike. That means that they would have a delivery bike ID. So this is what we will do in the beginning right here. So this means that I will actually say map by. I'll actually say join. One-to-one. I'll say one-to-one. So first of all, we'll need to mention what kind of relation it is. This is a one-to-one relation that we have right here. And then if we want the fruit basket to point to the delivery bike, then it's actually the fruit basket that will be the master. Then we will do it like this. And we'll say map by, and then we need to mention the field that we're going to create on the fruit basket. This means delivery bike. So this means I need to create this field. We need to create this member variable right here on the fruit basket side. So I'll say private delivery bike, and then we'll say delivery bike like this. And again, right now we get an error. And again, here we will say 1-to-1. This is 1-to-1. And then we will say join column. And then we will give the name of the joint, the name of the joint column. This could be delivery bike ID, like this. If you have no reason to not follow the standard, then just follow the standard right here. You will say delivery bike and then underscore ID. That is the name of the column on the fruit basket, and then this ID right here will actually point to the delivery bike. This actually means that there's actually a fruit basket that is the master in this situation right here. It is not the delivery bike. If you wanted the delivery bike could also have been master, then you just had to do the opposite. That means you would actually create the join column right here instead. So this is one way to create the mapping. 1-to-1, we have that right here, delivery bike, and we do not have any join columns or anything like that, because we have actually told JPA that all the mapping information is on the delivery bike on the other side of the join. That means on the fruit basket, delivery bike right here. Here we have the way to join these two. Let us create an example with Spring. So that means that we will actually create a repository. So we will say fruit basket repository. If you don't know Spring, if you don't know what a repository is, then the repository is just something that makes it easy for us to handle entities and to store, delete, update, insert new entities right here. So that we need to extend a JPA repository, and then we need to see what type does this handle. It handles a fruit basket and an integer that is the ID type. And we do not have to do anything else. Spring will actually create an implementation of this interface automatically. So we have this fruit basket repository, which is right here. That's quite good. Then we want to create. We can do the same with the delivery bike actually. So we can also create a delivery bike repository. Let us do that. Delivery bike repository. And again, we need to change the type right here to delivery bike. And here we have the delivery bike, and we have the fruit basket repositories right there. Now we can create some entities when our application starts up. The reason why, of course, we could also have done this in a test, but if we create a Spring Boot test, and as soon as our test stops, then the H2 database will actually also be stopped, and that means that then we cannot go into our web console and actually see what's going on. So that is why I want to create a new component right here. Let's right-click right here and say create fruits basket on startup. Of course, you can name this. You can name this whatever you want to name it. And here we have the fruit basket right here. Then we can say add post construct. This means that when Spring has created an instance of this class right here, then this method right here would actually be called. So here we have create some. And again, we use Lombok, so we will say required Ask constructor. What this does is that this will create a constructor with the fruit basket repository, and also with the delivery bike repository. So this will actually create this will automatically create a constructor with these two repositories right here, because they are private final, and that is where required Ask constructor is quite good with Lombok. So let us first, we know that the fruit basket, it's actually on the fruit basket. That's where we decide which bike that it should be attached to. So this means that we need to create the delivery bike first. So we will create a new delivery bike, save. It's quite easy to create a new delivery bike. We will just say, first of all, let us go back to the bike. We want to make it easy for us to actually create this bike, so we will say builder. And we will also add no Ask constructor. That means that they will get the default constructor and then all Ask constructor. And we want to do that. We want to give those three annotations on both of or entities. This is Lombok, and this just makes it easier for us, so we don't have to code so much. Then we will actually get a lot of code for free. This means that I will actually have a, if I now go to my delivery bike, then means that now I will actually have a builder with the builder pattern. If you don't know what the builder pattern is, then please look it up. It is awesome, and it will actually stop you from getting errors when you refactor your code and your entities. Because when if you change your constructors, then you would usually get an error around in your code. But if you use the builder pattern, you do not have that problem, because here you just mention, you just mention whatever you want to mention, and then the rest of the missing member variables would just be null if you create a new member variable. Description of this delivery bike right here. It could be red and fast. So this is a red and fast delivery bike. And then we have a owner, and this owner right here is Mike. So I own this delivery bike right here. And then we save it, and then we get the delivery bike from that. So then I want to check my fruit basket repository, and again, fruits basket repository. Then again, I choose save, and then I want to say, then I get my fruit basket like this, and again I use the builder pattern to build a fruit basket. I will say color. What fruit basket? This could be a nice brown color, right? That's a good color for a fruit basket. Max weight. That could be maybe this is 100 kilograms, and then we have. And that's it. Then we can set the delivery bike also. So it means that I can set my delivery bike like this. I actually don't need to have a reference to a fruit basket, but I'll just leave it for now. So this means that now we have actually created a delivery bike, and we have created a fruit basket, and we have linked them together on the master side right here by first creating the delivery bike so it gets an ID. Then when we set this, when we set the delivery bike on the fruit basket, then that ID will then be placed in the delivery bike _ ID on this table also. But let us see what it looks like when we start up our application. Before we start, I want to tell you that I have this is my data source set up I have right here, and right now it is actually right now it's actually a space. That is the name of the database. That's okay. And here we have the username SA, the password SA, and it is the H2 dialect that we have right here. The reason why the database name is space is because the other examples that I have, they are regarding spaceships and captains. And we will go through those in just a couple of minutes. Then what is actually important right here is that we have enabled the H2 console right here. This means that if I go to a browser afterwards, then I can actually access my H2 console. And the H2 console is a view into the database, so then I can actually write SQL skills manually, and then I can get data from it. That's quite awesome. Okay, so let us start up our application and see if we made any mistakes or errors. So, yeah. Or now we get this one right here. This is a classic one, and you'll probably also make this mistake a lot of times. It says right here, IDs must be manually assigned before calling save, and this is because we have not told JPA how should we get these IDs. It actually expects me to fill out the IDs, but we do not want to fill out IDs. IDs should come automatically from something called a sequence inside the database. So that means that we will say this is a generator value. We will set the strategy to auto, and this means that now we will actually get an ID automatically generated for the delivery bike, and of course we also need that for our fruit basket right here. Generator value, strategy type also, and then we try to start again. So that is a classic to forget, and this generation type also means that the JPA will actually choose what kind of strategy should be used, all depending on which database that you use. If you use a H2 database, then it will be something called a sequence. A sequence is just it's something inside a database where you can just get a unique number, and then there's a counter that will be incremented every time you get a unique number, and it starts with 1 and goes on and so forth. So let us actually see what actually happened right here. We actually started up. So now let us go to we will actually go to our application right here. So if I go to localhost, 8080, that's the default port. Then I log in with SA, connect to my H2 console right here. Then we can see I actually have a lot of tables, and that's because I have examples for the other types of relations also that we'll go into in just a minute. Here we have the delivery bike that is right here, and we can see in the left side that the delivery bike has a the delivery bike. It has an ID, it has a description, it has an owner. We can also see the type. This is the type. It has a character, a varchar 255. When I choose string, then that is what it was converted to. Then I have a color right here. Again, a varchar 255. If you want another type, you can actually also set the type. Just write a column on top of your properties, member variables, and then you can actually set what kind of type you want to have. Maybe you want to have a text type instead of just a varchar 255. Then we have max weight, and then we have the bike ID right here. So let us try to select some data. So first we will go and select the fruit basket, because that was a master. So let's just start with that. Here we can see it has an ID of 7. The color is brown, max weight 100, and it has a delivery bike ID of 6. So this means it is actually connected to the bike with an ID of 6. The reason why it doesn't start with 1 is because I'm also creating other objects in this project also, and this just means that that's why we have IDs before number or after number 1 right here. So let us try now we can actually see that we are connected to the delivery bike with an ID of 6. Now let us try to select from the delivery bike like this. Here we have it. Here we can say we have one bike, and it actually has the ID 6, and it's red and fast, and the owner is Mike. Now let us connect these together. So let us just do that. I'll say fruit basket, and I'll write an alias which is F, and then we have the delivery bike, which could be B for bike. And then we can create a join with the where. Then we can say where F dots, and that's actually a code completion, so you can write control space, and then you will get this list up here. That's the delivery bike ID equal to B dot, and again we get code completion. Then I can press Control Enter, and now I have joined these two tables together, and I actually got my result right here. So this is a one-to-one relation. It could have been created in 2 other ways, actually. We could have created it with a relation table in between. This means that we would have a table in between where we would have the relation. Then we would have a table with an ID of the delivery bike and also an ID of the fruit basket. This means an extra table. That is one way to join these two, even though it's one-to-one. And that is called the join table approach. I'll show an example of this in just a minute, just so don't... And then we have the third way to actually join two one-to-one, to make a one-to-one mapping, a one-to-one relation, is to actually use a shared primary key ID. So this means that if I on purpose actually gave the delivery bike the ID of 7, and I also gave the fruit basket the ID of 7, and then I actually knew that those two entities actually were together, were pointing to each other because they have the same ID, then that is called the primary key, the joint primary key mapping instead. I don't like that approach. I think this approach is actually okay, where you have a column that on one of the entities that then points to the other entity. The cleanest approach, of course, is to have the relation table in between. Now let us try to look at that code instead, because now you kind of have a hang of how actually to get started, and how to how to start from scratch, and how actually to set up these relations. We start with all of the primitives, or the primitive wrappers, and then we take the difficult part, which is of course the relation in between the delivery bike and also the fruit basket. And of course you can create more. You can create as many relations as you want to, because this fruit basket, it could actually have some. Maybe you could have a one-to-many, and then we could have some fruits right here, right? Then we can have some fruits, a list of fruits, and then of course we had to create that fruit entity. I will not do that because I have another example instead. So let us go look at the examples that have already been created right here. So we have a one-to-one with. Let's just look at the one-to-one first. So here we have the one-to-one example, and here we have the join table. So let us say if we want to use a join table. In this situation, we have a captain. I've prefixed all of these captain, all of the entities with join, just so we can see that we're using the join table strategy right here. Then we have a captain, and then we have a spaceship. And again, in this situation, a spaceship can only have one captain. A captain can only have one spaceship to rule over. And this is how we created that joins right here. So first of all, we have some fields, description, fuel on the spaceship, max speed on the spaceship. And then we have a one-to-one with the captain. And it's easier on this side right here because we have said that this is mapped by the ship property on the captain. So this means that there's actually no mapping information right here. The reason why I've added JSON ignore right here and to string exclude is because I don't want to have an infinite loop when I'm converting this to either JSON or if I am printing it out in my console log or in the log with the because or else since the two entities point to both to point to each other, then we would actually have an infinite loop when we try to create JSON from it, or if we try to create a string from them. But that's another story. So the join is on the ship property on the captain. So let us try to go look at the join captain. I can hold control and then I can click the captain right here. And then we should have look for a ship property. Yeah, we have a ship property right here. And here is the join. And in this situation, again, we have a captain with some fields on it. It has a name. He has a name. He or she has a name. Biography. And then we have the mapping type right here. One-to-one mapping. Then we have something called cascade. I'll not dig too far into that. That just means that if you, let's say that you delete the captain, then you would also delete the spaceship. This is what cascade means, and there are different types of cascade. Right now here, it's all of the cascade types. This means that we can. It's very easy to handle if we are on the captain side. But this video is not about the cascade part. It's a bit more advanced, so to say. Then we have the join table right here. Add join table. This you remember before we are on the fruit side, on the fruit basket, we actually had a join column instead, right? Let us just go back if you have forgotten. Here we have the join column that said delivery bike ID. Right now we are using a join table. This means that a whole new table will be created named captain space ship. Inside that table, then we will get two columns. One column where the ID of the captain is. And then we will have and that captain ID, it points to the ID of the captain right here. This is what this column. This is what this says right here. So we have a new. We'll have a new column named captain ID, and what it actually points to is the ID of the captain, which is right here up here. And the same with the inverse join column. This means that this will actually point to the spaceship ID. Or the new name on the new table will be named spaceship ID, and it will point to the ID of the spaceship. Quite awesome, and it's actually not that advanced as you can see right here. This just means please create a new table in between these two entities right here, and it is a one-to-one mapping. And that's it. And again, I have created some repositories, so it's easy for us to create new entities. And then I've created a component with, this time, again with post-construct, where we're actually creating some spaceships. We have a pyramid right here. Then I'm saving the pyramid. I'm saving the spaceship. And then I'm creating a captain. And then I'm saving the captain. And then in this situation, I'm actually creating each entity one by one, and then I connect them on the saved captain side. I say save captain, and I say set pyramid, and then I save it once again. Then I save the join captain once again. Yeah. So we have this right here. This should actually have been the save captain. So there was a small error actually there. Then I have created this event listener right here. This is just to show that there are different ways of calling methods on startup in Spring Boot. One of them is the post-construct way. The other one is to create an event listener and then actually listen to the started event like this. And again, this method would actually be called. And in this situation right here, I'm creating a box spaceship. The box spaceship is right here. Fuel percentage of 44%, max speed of 11, whatever units that is in. And then we're saving the spaceship with the box, and then we are creating the captain right here. And actually this time, let us just set the ship also. Let us set that to the box. Then we can save some code, and then we can just save it like this. Let us try that instead, because this means that we will actually already have the ID. The important part is that we save the box first, so we actually get the ID. Oh yeah, okay, we're using the joint method. Okay, we need the ID of both before we can do this. With the joint, it is a bit important what kind of type of relation that we have, because in this situation we are creating a new table, and that new table needs to know the ID of each of the entities, and the way to get an ID is actually first to save the spaceship, and then we save the captain afterwards. This means now we have an ID on both of these entities, and then we can join them together. Then we can join them together with this by setting the spaceship on the captain side, and then we save the captain once again. So first we create the captain, and then we save the captain with the then we save the captain with the spaceship attached to it. Yes. Let us start the application again, and then we need to go and look at this the joint spaceship tables. So we will go back again to my H2. Let us just refresh, because since I restarted my application, then it's actually a whole new database instance that I got right here. So I'll save this again, and again we have a lot of tables. Let us go to join captain. Go to join captain like this, and select what we have here. We have Brian and we have Paul. One of them has ID 2, another one has ID 25. And then let us look at the join spaceship. So join spaceship, it has a box and it has a pyramid. How are these related, and how are these joined? How can we see that? They are joined with the join. What did we name that table? Let me just go back. I have to see what I named the table. Captain _ space _ ship. So captain spaceship, that was the name. So it's actually up here. So this means that if I select from the captain spaceship right here, then I can see that spaceship 1 is connected to captain 2, and that spaceship 24 is connected to captain 25. Okay, so let us try. This is our join table, so I'll alias this with J, and then we will say join captain. That could be C for captain, and we will have the join. Then we'll have the join spaceship right there. That could be S. And then again, I just create my relation right here. I say s.id equals to j dots, and here we have the spaceship ID, and c.id equal to j dot captain ID, like this. So now we can actually see that Brian is the captain of pyramid, Paul is the captain of the box spaceship, and we have joined these two tables together with the extra. We got an extra table, but just to see how clean the tables actually are. We do not have any column that actually points. We do not have any extra columns into in the entity tables. Right here we have the joint captain, we have the joint spaceship, and there's no extra. We only have the columns that are actually related to each of these objects. So this is the cleanest way. If you are in any doubts, then use this way to actually join your entities. Because the good thing right here is that let's say that you decide that it's not a one-to-one relation. It is actually a relation where you can have a captain can actually be a captain of a fleet, maybe of 5 spaceships instead, or many spaceships, as many spaceships as he or she wants. Then it would certainly be a one-to-many relation, and then it's very easy to change that relation to one-to-many, but you just change it in the JPA, and there's no need for changing the database. You might already have a version of your application that is out on a lot of environments, and maybe or even in production, and then you would actually have a lot of cleaning up and some but you would not have to clean anything up with this by using the join tables right here. So this is the cleanest way to join two entities, because right now it's one-to-one, but maybe tomorrow it could be a many-to-one instead. One-to-many. Yeah, so that was a joint table example. Then we have the shared key example, and this is the worst solution, I would say. So we have the shared. That is actually where we would know that the ID of the captain is the same as the ID of the spaceship, and therefore they are connected together. The way that we connect these is by, first of all, we have to create our entities, of course. So we have the name, we have the bio, and then we have to say that we want to point to the spaceship, the shared spaceship. I have prefixed these with shared because it is a shared primary key. And on one side, we have to say that the join column right here is captain ID, and that the maps ID, the reason why we have maps ID is actually because that we will actually have the ID mapped to this ID right here. So yeah, so this means that the maps ID means it will steal ID from the spaceship and it will actually place it right there. That's what it means. If we go to shared spaceship right here, then we will say primary key join column. So again, this means that that we will actually have the same ID right here as we will have on the on the captain side. And again, we are saying here that this is a one-to-one mapping, and then we say, please don't look too much into the mapping itself. You have to go look at the other entity. Whenever you see map by, this means go look at the other entity and look at the ship member variable or property, and then there you can actually see how it's actually mapped. And the cascade, we have already talked about that. So so this means that it's actually mentioned here on this side right here. And again, we have some examples. So if we go to the database, then we can actually see that we have a shared captain right here. So here you can see we have Brian, which has captain 3, which has captain with ID 3, and then we have a spaceship right there. It also has an ID of 3. So this means that Brian is now captain of the spaceship 3. This is the ugliest way because you actually infer that the IDs are equal to each other. And if you ever want to change the mapping right here, then it's no fun. So I would definitely not recommend that way. That is the shared primary key approach. Don't do that. So what else do we have? So then we have then we actually come to the many-to-many. We have one-to-many, and we have many-to-many joins. The one-to-many are actually just like, those are just like the one-to-one. So you can use exactly the same principles. Right here we have a cargo ship in this situation right here. And here we have a one-to-many mapping right here. Again, except for this word is now one-to-many. Again, we can see here it says map by. This means, okay, the mapping is not on this side. We have to go to look at the cargo ship side. And look what's here now. Now we have a list instead. This is because we can have many cargo pieces of cargo inside the cargo ship. And it's all mapped on the cargo side by on the cargo ship member variable on the cargo ship field. So let us go to cargo and see what it looks like there. Here you can see here's the cargo ship. Okay, how is it joined? It's joined with the join column. We have not used the join table here. We have just used the join column. This means that each of pieces of cargo will actually have an ID where the matching which spaceship it's actually placed in right now is set. So this is how it's done right here. As you can see, it's almost like one-to-one. The difference is that we have one-to-many, of course, and we have a list right here. That is the big difference. So, and again here we have many-to-one right here instead of one-to-many. So yeah, it kind of says itself. And again here, what would I recommend? If you're in any doubt, then use the join table. And I have the join table example right here. Here we have the joint cargo ship example right here. We have one-to-many. We have one ship can have many pieces of cargo. And again, on this side, there's no change. We will just say that it's mapped by the cargo ship fields. So then we will go to the joint cargo right here, and then we'll go to the cargo ship field. And here you can see It's a join table. Okay, this means we will get a totally new table named join cargo underscore join cargo ship. Of course, you can set this name to whatever you want to. It just needs to be clear that this is actually a relational table. Then we have a join column. This means that we join the cargo ID with the cargo ship ID right here. So this is quite awesome. It's quite simple again. Join cargo and join cargo ship. Now let us look at the many-to-many, because this is what some people think, for some reason, then they actually think that this is difficult. It is actually just as easy. It's actually the easiest way. That's actually if it's many-to-many. In this situation right here, we have some crew members. The crew members can have skills. The same skill can actually occur on multiple crew members. So that means on the skill side, we will have many-to-many. So that means that one skill can actually be attached to many crew members. And one crew member can have this, many skills. So this is a many-to-many situation. And the good thing about this is that only one way to map this. So this is the simplest form of relation. You need the join table right here. So we have the table in between with a name, with a join column name right here, and with an inverse, the inverse join column also. And here we have the skill ID. So crew ID in one column, skill ID in another column. And the reason why it says columns, join columns in plural, and inverse join columns also in plural, that is because you can have something called a composite key. You can have composite IDs actually. So that is why you can actually join. Sometimes in some table designs, you will actually have to use multiple columns to uniquely identify a row, and that is very wrong. So always have one ID. Have one ID on each row. Do not, if you don't have a really good reason for using composite IDs, then do not use composite IDs. They will just make everything much harder, and they do not provide much value. In my opinion, at least. So let us look at the joint many-to-many relation in our database. How does that look? So we will look right here, many-to-many. Where do we have the skills? So the skills are right there. That is the skill. And we have 3 skills: math, flying, and avoid asteroids. And we have some crew members. They are here. So let us just select from the crew members also. The crew members are Mike, Jane, and Lina, or Line. And then we have the relation. We have the join table, and that is named, what was that named? That was named crew member skills. Like this. And here we can see we have crew member 11 and 11 has skill 8 and 9. Crew member 12 and 12 has 8 and 9. And then and also 10. Crew member 12 also have to have skill 10. And then we have crew member 13 has only a skill 9. So let us try to join this again together, and let's see what actually happens. So this is our join table. I'll just alias this with J. Then we have the skill, which is S, crew member, which could be C for crew. And then we say where C.id equal to J.crew members crew ID, and S.id equal to skills skill ID. Where's the end? The end is right there. And we did something, we made an error somewhere. Select stuff from crew member and skills S. C.id does not. Okay, it's because this is actually crew member. This is because I've named the IDs to something different. It's crew ID. Yes. That's okay. So we will say crew ID, and is it also skill ID? Then it probably, yes, it is skill ID. Skill ID. So okay, so now we actually got them joined here. We can see Mike has math, Mike has flying, Jane has math, Jane has flying, Jane has avoid asteroids skills, Lina has flying. So this is how it is with the many-to-many relations. It's actually the easiest one, and it's also the cleanest one. If you're in any doubt, so the approach is whenever you get a problem, whenever you get something that you need to do, start with creating the entity, like we did in the fruit example right here. We started with creating the bike, which it should always have an ID, so you can actually always just write that ID, generate value, auto. And also, of course, start with entity. And if you need to set the table name or the schema, then use add table right here. Then you can actually say, you can actually set the name, and it could be something else, totally else, like bike, something like that, just bike if you don't want the delivery part in it. And you can also set the schema if that is needed. But I think the schema should be set by properties and globally. So I'd actually say do not mention table unless you really have to. And again, the same with the columns. Do not annotate with columns unless you really have to. Let's say you want to just define the type. Also, then you can. Then we can also do that some way. Yeah, column definition right here. And of course, that could be something like text. Yeah. So that is a start. That is a setup. But try not to use the add column, and try not to use add table if you don't have a good reason for doing that. And then when you're done with all of your properties, when you're done with all of those, then you can. When you're done with all of your properties, then you can actually then you would actually say what kind of object you want. So then you would actually have the object, and then you need to say how should it be mapped. In each situation, it's quite easy. It will be mapped on the fruit basket side, and it will be on the field delivery bike. We go down here and look, and here we can see it's a join column. This means we would get an extra column on the fruit basket side named delivery bike ID. So this is not the cleanest way, but it works. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool things coming up. Bye.